What do we have to do to make thrive? Not just survive, but thrive.
Let's go to space.
Welcome everybody to Fridays with Tim. Today is March 4th, 2022. I am Tim Alatorre, Chief Operating Officer for Orbital Assembly Corporation. And we'll give people just a second here to join. And we'll go ahead and get started. So as always, feel free to enter your questions into chat, and I'll get to those as we go along today. And if you'd like to ask a question live, feel free to raise your hand, and I'll try to get over to you. To start with, just wanted to highlight a couple of things that have happened over the last month, I guess, since we last met. So first off, many of you probably saw that we sent out a press release yesterday announcing 2 new board members that have joined our board of directors. That's Drew Wall and Bill Toski. And we're really excited to have them as part of the board of directors. Both Drew and Bill work for a company called IG Partners. Drew was actually the founder of that, but they both joined the board kind of independently. And each of them has decades and decades of business experience, Bill specifically with aerospace, and both of them have been in the trenches of raising capital, taking startups from nothing to a multi-million, and in one case, $1 billion company. And so their expertise and experience has been a real help to us. And we're really excited as we move forward, kind of ending the net capital round, which is ongoing, and getting into our Reg D Series A funding round starting later this year. Looking forward to their continued input and insight. Also, just a reminder, our net capital raise is still going on. And if you haven't had a chance to invest there, we encourage you to go check that out. Also, 2 other things, more of a community sort of announcement. We have 2 things that we're going to be kicking off this coming month of March. One, starting in a week or 2, we're going to be kicking off an art contest. We're going to be holding a contest for people to create space travel posters, and we have some really exciting prizes for that. And there'll be different age categories as well as an adult category. So more details to come on that. And then also Jeff Greenblatt, who is one of our co-founders, he's going to be kicking off this coming month another video series to complement the one I'm doing here with Fridays with Tim, but it'll be more focused on the space ecosystem and kind of the bigger issues regarding space. So these calls that I'm doing, which are now monthly, Fridays with Tim, these are focused very much on what's happening specifically with Orbital Assembly Corporation, our progress and the things that we're doing. And Jeff's program is going to focus on how what we're doing really interfaces and connects with everything else happening in space, and bringing in some other outside people. And then the last, community piece that I'm excited to announce is one of our advisory board members, Frank White, is going to be starting a series of articles that we're going to be posting on our website. The first one should be coming out in a couple weeks. And many of you will know Frank from his book, The Overview Effect, and he's going to be sharing his thoughts, again, not specifically necessarily championing and being a cheerleader for what we're doing, but talking more about the implications of what we're doing and how they fit into the broader space community and also just humanity, and how what we're doing is really going to be a benefit for humanity. A lot of comments that I see on social media is, people don't really understand why space, why artificial gravity, how artificial gravity works. And especially with, a lot of the things happening right now in the world, space almost seems like an afterthought. And I think Frank's going to bring a real clarity to why humanity pushing out into space not only is exciting and an adventurous thing, but also is going to help Earth and what's happening here with culture and economies on Earth. So really looking forward to those 2 things. Or I guess 3 things. That was 3 things. Okay, so now going to your questions. Let's see, we got a question from John. Wanted to know a bit more about the debris issue that was brought up in the last call, I guess. So my guess is, John, and feel free to drop some more clarification in the chat. How do we deal with orbital debris? So this is a question we get asked quite a bit, and it's in the news a lot, right? I think one thing to understand first off is space is incredibly big. If you think about just the surface of the Earth and the chance for you to run into any random object at any given time is pretty slim, right? I think one of the scary things about space is things are moving at an incredibly fast speed, and so your response time is very short. So there's two types of debris on orbit that we're primarily concerned with. One would be debris that we can track and that we know where it is. And there's actually, so the government does very good tracking, and they know where most, larger pieces, kind of like 10 centimeters and bigger is really what we're able to track. And they know where that's at. And actually, it might even be smaller than 10 centimeters, but somewhere in that range. There's actually a private company also that we've been in contact with who is trying to track debris on a much finer and more accurate resolution. And so we're really excited to get that tracking information, both what the government provides with the DoD tracking, and then also what private companies are looking to do. So if we can track the debris, then that's a relatively easy thing for us to maneuver out of its way. Usually, several orbits in advance before something is going to make impact with you, and so you have time to adjust your orbit and move out of the way. I think the thing that's more terrifying, I guess, or that causes people more concern are the pieces of debris that you can't track, right? And so the International Space Station actually has been dealing with this now for 20 years. And there was a couple years ago, NASA did a very exhaustive survey where they collated all of the different impact reports over the years. And NASA does regular inspections, and they're constantly checking what's happening as far as impacts on the station. And they did a pretty good report of the issues related to that. So for all of the critical components of the International Space Station, they use a shielding device called a Whipple shield. And it's usually, the thickness varies, but and in fact, if I had the stats up here, I could tell you exactly what it is. I'm trying to remember off the top of my head. It's between like 5 and 10 or so centimeters thick. But you have layers of aluminum and different Kevlar and Nextel fabrics. So you have a piece of debris that impacts that outer shield, which is called a bumper. It fragments, dissipating the energy, and then that continues to fragment and get absorbed with the energy of all these different layers until by the time, if a piece of debris were to hit the pressure vessel, it's not traveling at a velocity that could do any damage. So we would be using similar shielding. And then there's certain systems that you just don't or can't shield, like the solar panels. And so you build in redundancy so that if you have one point of impact or failure, the whole system doesn't collapse. And last year, we were actually meeting with one of our potential vendors who'd be providing the radiators. Because you have to get rid of a lot of heat on the space station. You basically have a little can that you're cooking. And so radiating heat is a real critical piece. And their radiator system, actually, they're doing some real cool next-gen radiator designs. And they're designed to be able to take multiple impacts to the radiators and still keep functioning. So that's another approach, redundancy. Obviously, you don't want pressure vessels to be damaged. Then you develop a leak. Most leaks it's not like what you see in the movies where you get a little pinprick and everybody gets sucked out in the vacuum of space, right? You would have to have a very large piece come in and impact the station to have a catastrophic failure. And those things we can track. And so the smaller things, even if there were a small breach of the pressure vessel, we could patch that before it became catastrophic. Also, on station, we have a lot of life support systems that we're designing in. I've got Voyager behind me today. And all of these vehicles on the rim, those are all just emergency vehicles. Those are ERVs for medical or catastrophic failure where we have to evacuate the station. Just like currently on ISS, they always keep vehicles docked there for emergency evacuations, and that's what we're doing here. So in the case of a serious breach, we could completely empty the station. Also, we're developing some other, the stations itself have bulkheads and ways to lock down certain portions. So if there was a significant impacted piece of the station, we could close that off. And then within the station modules themselves, we're actually designing some life support capsules to where you could jump in this little like safe room until somebody could, and it'd be pressurized with oxygen and everything until somebody could come and do an extraction. So debris and safety are paramount with being in space, and we've given a lot of thought to it, and we're constantly reevaluating and relooking at our risk tolerances and ranking risks, and not something that we're taking lightly. So hopefully, John, that provided some additional context for you. Let's see, next question. Okay, Benny's asking, would you be able to pour water into a cup with artificial gravity? So yes, and the question there would be how much artificial gravity, right? At lunar gravity, things fall about 1/6 as fast as they do here on Earth. And in microgravity, they don't really fall. You just get a bubble of water that starts to form. So there's going to be a certain level of gravity where that bubble would move at a fast enough pace in the direction of your cup where you could catch it, right? Like if you poured it too fast, you're going to get this huge bubble, and by the time it settles down and hits your cup, you're going to just have water everywhere. So you'll probably want to adjust your pour speed and the distance of your cup to get it just right. It's going to be a fun, there'll be lots of fun experiments. Pioneer Station, when it's first launched, the gravity level for tourists, because we're trying to keep things around 1.5 to 2 RPM on the rotation speed of the station, so people don't, feel nauseous, and you're probably not going to be able to pour that water too fast because the gravity, the pull on that will be relatively low. But on Pioneer, we could, crank it up with some people who've trained and acclimated to the rotation, to where we could get, maybe lunar and Mars G on Pioneer, and at that point, you should be able to pour water relatively normally. And at lunar G in particular, you would be able to, and you can set your cup on the table, and it's not gonna float away. The water will stay in the cup. And Wes points out the flow won't be exactly straight down because of the rotation, and that is actually really true. There's a new image for the interior of Voyager Station that should be coming out, and you'll start seeing it in media and stuff in the next week or so. And it's actually an image that I had started creating last year for a campaign that we were going to run at Astro Magazine, and it got canceled for a number of reasons. But I'm polishing up and cleaning up, and we're going to publish it. But in there, it's an image of the restaurant and the bar. And one of the cool ideas I had would be to have laminar flow fountain coming off the ceiling of the module and having it come into this little fountain, because you would see the curvature of the water. And I thought it'd be really cool to have maybe like, and you'll see this in the image when it comes out, but little dishes, like little plates, one for Earth, one for the Moon, and one for Earth, one for Mars, one for the Moon, because depending on the rotation speed, that water is going to curve less and less. So for lunar gravity, you're going to see more curvature, and then as you start to increase the speed of the station, you'd start to get more towards 1G, and the water would fall, and you wouldn't see as much curvature. So yeah, the physics on that are actually pretty cool. Okay, so let's see. Matthew's asking, how much of the engineering work is software computer network, and will you be hiring for any tech positions? Yes, on the second position, or second question, there will be tech positions. I had an opportunity a year or two ago to talk with the team that developed ISS, and one of their comments was that the hardware side of building the International Space Station was actually the easy part, relatively speaking. The software was the part that was the most complicated. Now, since 1998, when the first module of ISS launched, to today, computer technology has advanced quite a bit, right? If you think about the computers you were using back in 1998 and just programming in general, it was a lot more complicated. But still, yeah, the software and the control systems are really, going to involve quite a bit of work. The control systems in particular, though, are going to be driven by a series of algorithms. to be able to control the station in rotation, those algorithms actually are one of the key components. So, and that comes into dynamics. And so, one of our next hires will be a skilled dynamicist. And we're working right now with ASU. Their students, we're doing a project with them where they're doing some dynamics analysis on the gravity ring, and showing what happens with different perturbations in the rotation, and firing thrusters at different times and things. So they're doing some of that initial legwork there, which is really exciting. Let's see. John's asking, any changes in timeline causing extending this raise? The timeline isn't really related to the extension of the raise, no. The extension of the raise does in a small way affect the timeline, just because the time, this extra month means we're not getting into the Reg D as fast as we had thought, but doesn't really impact the schedule, the master schedule of getting to launch that much, if at all. Benny asks, but if it's not touching the moving gravity, it would be weightless. Well, so this is actually an interesting question, Benny, and something that I've seen in comment threads here and there. Everything inside the modules is touching something. The atmosphere, all of the atmosphere is moving with the module. So and when you lift off from, like if you were to jump or drop something, it still has some momentum. That object, even when you let go of it, it's still moving in the velocity it was when you let go of it, and there's some minor resistance from the atmosphere. So not entirely weightless. It wouldn't just like float there, because it has momentum still. Okay, we'll pop over to Aiden here. I see he's got his hand raised. So Aiden, feel free to unmute. Good to see you here.
Thank you. I was going to ask, do you or any other board member plan to travel to the Pioneer class station once it is complete?
Oh, absolutely. Yes. Yeah, I think most of, well, the executive team, I would say in particular, we all want to go to Pioneer and Voyager stations. Our new board members, Drew and Bill, I actually haven't asked them if they want to go to space. But yeah, I'll have to ask them the next time I talk to them. But yeah, for my part, Tom, Rhonda, Jeff, Tom, Eric, Tim, C, Shauna, all the other people involved. Yeah, we definitely want to go. And yeah, any excuse we can get to go. Now, Pioneer is going to be a much smaller station when it's first operational. We're estimating a capacity of around 28 people. So the cost of ticket and getting up there will be higher. So we'll have to have a really compelling reason for one of us to go up. Voyager Station, by the time we launch that, by 2027, launch costs, we anticipate going a lot lower. I talked about this last month when we had the call. Launch costs are falling dramatically. Just in the last 10, 15 years, launch costs are about 75% less than what they were. And that's factoring in, the Falcon 9 and the Neutron, which Rocket Labs has announced. But then you factor in Starship, when that goes online, the numbers Elon Musk are talking about, those are like 99% reductions over the $8,000 a kilogram historical average. So that starts to open up space to a lot of people. And when you have a station that can hold 400 people, then you can start to, amateurize the expense of building the station over time and over all those people, to where ticket prices start to become really realistic. So, or I should say reasonable, right? I mean, hopefully everybody on this call will have an opportunity to go to Voyager. Let's see. Wes is asking, only outside of the station or in the center hub? Oh, this is back to the gravity portion. Yeah, in the center of the station, you would be weightless. Anything along that rotational axis would be weightless. If you're outside the station, like if you're walking along, this outer ring here, because you're in contact with the station, you would still have that momentum creating the sense of gravity. So if you jumped, you still have momentum in the direction of rotation. So you would eventually, you would hit the ground again. But any approaching spacecraft, you're in microgravity. If you have the unfortunate, experience of launching yourself off the space station, not being tethered, you would go flying off in whatever direction it was when so if you're here and the station's, you say, well, see if I can do this backwards. If we're rotating like this, nope, wrong way. There we go. And you launch off, you'd fly out that way. You would feel weightless because you're just basically falling forever. Yeah, space darts, Alan mentions. So that's something that's really cool, and I'm excited about. Artificial gravity opens up a lot of options for different games and sports and things. So there's some early shots of Voyager where we showed the gym with basketball and people are jumping like 15 feet. You'll be able to jump 6 times higher than you can here on Earth. So in lunar gravity. So there's a lot of interesting opportunities for sports and darts in particular, because your darts aren't going to be flying how they are here on Earth, right? You have to reprogram your brain. Let's see. So Benny's asking, so a bird could fly in the station? Yes. In fact, there was a study that I can't remember who did it. I think it was a university, might have been partnering with NASA, but they released pigeons on the Vomit Comet. That's the plane that takes off and it does this parabolic arch, creating periods of microgravity. Basically, you're in free fall. The plane fall was the path of free fall, so you feel weightless. And they released birds, and the birds were able to fly because there's still atmosphere. The challenging thing, though, for the birds is they were disoriented. They couldn't figure out which way was up, and so they ended up kind of just flapping around and doing circles and slowly moving in a direction. So with the rotation of the station, there would be a sense of down because there's a certain amount of gravity. It'll be interesting to know, how much gravity, how much force is needed to where the birds can orient themselves and fly in a straight line. I'm sure that experiment will be done at some point. Let's see. John's asking, looking back at the spaceship entering the center core of the Voyager station in the video, it looks a lot like SpaceX's Starship. Any chance you had a heads up? So Starship has actually been in the works for some time. And as soon as SpaceX announced it, we put a Starship-inspired ship, in our rendering. So this right here is, kind of Starship-inspired, docked here to Voyager. And we're huge SpaceX fans and looking forward to them getting that flying. Something really exciting about Starship, especially with the recent announcement that Elon Musk made, is he's looking at taking potentially 150 tons to low Earth orbit. That's a lot of cargo. We were initially estimating that we could take potentially 100 tourists at a time or 100 passengers to Voyager, but 100 passengers isn't going to add up to 150 metric tons, right? So there's a lot of. We've been talking about the potential commercial impacts of that and how we can utilize all that mass capacity. Something to keep in mind also is 150 tons to LEO doesn't equate to 150 tons of people, because you have chairs and life support system and all the interiors, and people are really needy. We have a lot of demands. Just straight cargo, 150 tons, just like raw materials. Now, that's quite a bit. What'll be interesting too, and I haven't seen any numbers on this, and SpaceX's user guide is still a little vague, but the down mass, how much can they then return from orbit to Earth? That'll be an interesting component, especially as we start talking about orbital manufacturing and industry. Okay, getting close to the end of the questions here and time. Let's see here. And Chuck asks, is there anything in the works for us to get some type of international agreement for people/countries to stop blowing stuff up in space? Not that I'm aware of. Unfortunately, I am not on the government side of things. We do have one of our contractors. We have a contractor who we've been working with for, I guess, about a year or so now. And he is very much embedded in the DoD and the Washington, circles and what's going on there, and knows kind of all the different things. Not everything has been declassified, right? So I get things that are available for public release. I don't know if there's anything in the works. There are treaties in place right now for people not to be blowing stuff up, especially in higher orbits. But as you know, not everybody in the world signs those treaties, and then there's always the issue of people just ignoring it. So it's one of those things where over time, I hope that situation improves. Okay, last question here from Aiden. How about you hop on here? You'll be our last question for the day, and then we'll part. So go ahead.
Thank you. Can the Pioneer class station be used as a particle accelerator? Or maybe the Voyager class station also?
Yeah, so that's that. You always have some of the most interesting questions, Aiden. I think one of the challenges with particle accelerators is you really need a lot of size. If you look at like the Large Hadron Collider, that's at a kilometer scale. That's a very large device. You could accelerate particles over a short distance, but I'm not sure what that would give you as far as usable data. And then, like Mark was saying as well, there's significant power requirements for that. On Voyager Station, we're going to be having quite a bit of electrical power, so that might not necessarily be as big of a constraint, but I think the distance. I guess you could do, if you were to, okay, so now you got now you got my engineering hat on. I'm trying to solve this problem. On the access tube, which is continuous around Voyager Station, it does the whole loop. I guess you could line that with some electromagnets and just send stuff flying around, over a long period of time. I think we probably want to purposely build a station for that, as opposed to having that kind of equipment on a station with a bunch of tourists. That would be my initial thought. But the methodology we're developing to build these large stations really can be applied to all sorts of applications, and maybe more of a purpose-built platform. So, space solar power, where we're collecting large amounts of solar energy and then transmitting it down to Earth. Deep space telescopes, refueling platforms. There, asteroid mining and material processing platforms. There's a lot of things that our technology can be used for, and as we start to build up the space economy, those jobs and those opportunities are gonna move out and be available on orbit. So I wouldn't say never. I think at some point, these might be realistic opportunities. So with that, we'll wrap up this call, and just thanks again for everybody who's joining on these calls, and a lot of familiar faces, and it always surprises me the questions you guys come up with. Just a lot of great questions. So it keeps me on my toes. Our next call is slated for let's see, we're in March, so April, and that should be at the conclusion of our raise. And also, look out for social media and your email for, like I said, the new series being started by Jeff, articles from Frank White, and then our poster contest, which I'm looking forward to. That's a little bit of fun for what we're doing. And then just last pitch, if you haven't already, please go to our Net Capital page and consider investing. Every little bit does help. If nothing else, we talked about some of the reasons for the raise earlier. If nothing else, having that bigger number in our raise looks really attractive to future larger investors. Are like, wow, okay, you guys, you have a lot of fans. That speaks to the customer base as well. But if you're not interested in investing, no pressure. And thanks for being a supporter. Okay, so with that, thank you everybody, and we'll talk to you next month.